We are very thankful for the many companies and people that help us create wonderful content. So this slide acknowledges them. So thank you to everybody that helped us put this together. This is not an individual effort. This is a group effort. Evan Sheely, why don't you come on? Tell us a little bit about the great company known as Secor. Welcome, Evan.
Thanks, Peter. Yeah, no, thanks for the introduction. And Secor is thrilled to be here as always. It's always exciting to be a part of these webinars. Secor, to give you a little background, is a very large distributor of HDPE pipe and a manufacturer of fabricated fittings as well. We're very proud to be a supporter and be a partner with the Alliance for now over a decade. And we're always excited to educate the public on the many advantages of HDPE pipe and HDPE fitting systems. We'll also be joined by my colleague, Mark Christensen. He'll be on the panel today sharing knowledge on today's topic. So, thanks again, Peter, for having us. It's always really exciting for us to be a part of the Alliance.
Well, you guys do a great job, Evan, and thank you. You've given me a tour of one of your facilities down in Houston, and you guys do a lot of polyethylene fabrication. You move a lot of pipe, and you service a lot of customers very well. So hats off to you and your team. So thank you for helping us fund these efforts, Evan.
Absolutely.
All right, so today we've got a variety of speakers. I'm not going to individually introduce them today because we have several, but Mike Leathers, who used to be in the concrete business, has a fair amount of knowledge on the topic. Mike James, who's a familiar face to many of you, he's with ISCO. He's going to help us talk through some of the content. And Mike Camera with Lyondell, one of our members and a resin producer. So they take those gases from the wellhead and convert them to polyethylene pipe. And then, of course, Evan Sheely just introduced Mark Christensen. So welcome to our primary speakers today. Thank you for helping make some great content. Next slide, please. And then we also have what we call the bench. This bench answers just about any polyethylene related question that you may come up with. So please use the Q&A function. And Matt Damish, Dan Landy, Brian Swanson, who didn't make the list, sorry about that, Brian, Alan, myself, and John will all answer these questions today. Alan Ambler.
All right. So just like all of the Alliance's programs here, Peter, we also have that bench who's answering your questions directly and immediately. So definitely type those in, and then they'll get these fellas there. We'll work on it for you. We do have 2 poll questions that I'm going to launch right now back to back. So do us a favor to see if you can give us those poll answers pretty quickly. And then I'm going to talk about PDHs and CEUs, Peter. At the end of this presentation, we will have an end survey that basically you tell us what state you're in and what CEU or PDH license you need, and we'll make sure to throw that together for you. And you have your documentation now across the country, in Florida and maybe some other states. The need for documentation on those CEUs and PDHs is starting to increase a little bit. So we'll make sure to try to get that to you in a timely manner. That will be the quickest way that you could possibly get this CEU and PDH for it as well, by completing all the way to the end of the survey. And we'll tell you that again through this process. Okay, thank you very much, Pete.
Yeah, I like that question, Alan. Go ahead to the second one. We do use a lot of this data in our presentations of why people switch and what their concerns are about using polyethylene. So here's the adoption. So 47% of the 400 people that are on the call today are already using polyethylene pipe. PVC has more widespread adoption, therefore less risk for clients. Okay, that's a legitimate statement. Very interesting. All right, let's go to the next one, Alan. Thank you, everybody, for responding. All right. Oh, this is a good one. So we've learned in the past, what percent of your construction is open cut? That about half, let's see if it's true this year, of your projects are open cut versus other materials. And all right, so we have spent a fair amount of time in the webinar program talking about native backfill, Alan. And what we're really, really concerned about, as with all materials, is point loads. And on a 10-inch diameter DIP or DIPS size polyethylene pipe, we're looking for no more than 1-inch particle size. So those rocks can't be bigger than 1 inch. All right, let's hold this for about 10 more seconds. So on this slide, please take a shot of this. This tells us who our speakers are and what their email addresses are. Please feel free to bypass us and go directly to those speakers. We want to get information to you as quickly and easily as possible. All right, Alan, that's been held up long enough. Let's take a look at the results. And wow, 50% of the people say 75% or greater. Very interesting data. All right, really good stuff. We should, Alan, we should compile all this stuff and publish it to everybody. All right, so you've had time to look at that. That slide. Here's the last one that Alan's going to let me talk about today. Polyethylene is yet another pipe in a long list of ways we convey water and sewer from A to B. 6,000 years ago, we started with open trench. We then moved from open trench to lead pipe. Some say the Roman Empire fell because the wealthy people, who were the only ones that could afford pipe, poisoned themselves and became less intelligent, shall we say. Cast iron pipe followed wood. Ductile iron replaced cast. And then many say that PVC is replacing ductile. The pipes and the ability to convey and install pipes, the methods keep getting better and better and better. Ductile iron was a good pipe in the day. PVC was even better. But now polyethylene is the best. And hopefully some of you already agree with that. And with that, I'd like to introduce my good friend, Mike Leathers, CEO of Pipeline Plastics, one of our members. Mike, come on. So before you get started, Mike, why don't you tell us a little bit about who you are and what you do? Oh, and as Mike's working with his video here, can we just all agree to use Q&A with your questions? That would be great, because we can't track questions and follow up with you if it's in chat. So with that, Mike Leathers, tell us who you are and what you do.
Thanks, Peter. Sorry, I was having a little video problem, but my name is Mike Leathers. I'm the CEO of Pipeline Plastics. We're obviously the favorite association member for PE Alliance, and then also the favorite manufacturer for C-Corp. We manufacture everything up to 65-inch in the U.S., and I had a history of managing some great companies that made PCCP as well as other large water transmission pipe over my career. And so it's some products that are near and dear to my heart, and also some products that I know are coming to a point where you need some rehab options and some things of that nature. So I'm excited to be here.
Well, you know, Mike, the reason Alan and I wanted to do this is because we're getting a lot more demand for people wanting to slip line concrete with polyethylene. And people are seeing what you just said, and that is concrete that was put in the 70s and 80s, and in some cases the 90s, is already failing. So polyethylene, now that we can make it with in even larger diameters at very high pressures, people are seeing polyethylene as a potential source. So with that, I'll fade into the background. Mike Leathers, take it away.
All right. So I appreciate that, Peter, and everybody, and thanks for being here. So one of the things that we feel is important, and when you're talking about rehab, is to understand the pipe that may need to be replaced or rehabbed. And as you may know, PCCP has been around since the early 40s and 50s. LCP was first, and then ECP was next, just meaning that was a lined concrete cylinder pipe or an encased in concrete cylinder pipe. They were created kind of for the limitations of pipes of the time, such as cast iron and steel and RCP. They're really driven by the need for high strength corrosion and resistance and durable pressure pipe. So it provided a great solution for 16 to 144-inch pipe, up to 250 pounds of operating pressure, and sometimes can be designed for even more than that. Much of this large diameter is starting to be replaced with steel pressure pipe and HDPE and some others. And some of the smaller diameter that used to be LCP is now starting to be replaced by ductile PVC and HDPE in those capabilities as well. Next slide. So it was created to provide tensile strength to concrete. So the pre-stressing wires, as you can see, helped enable that and give tensile strength to that concrete by also creating a thinner wall concrete, which could create some reduce some of your costs and things of that nature. This steel cylinder was then added inside that concrete or on the interior of that concrete if it's lined instead of encased. And that gives you that watertight membrane with the concrete, and then the wires being put around it also reduce that cost with a thinner gauge steel. Then this steel and this wire has to be protected from corrosion, and that's accomplished with embedding it or lining it, and then on the wire, basically coating it. So all this was providing diameters that can exceed what we were seeing at the time in cast iron and some others. It also helped create some deeper installation requirements for some live loads. And this was accomplished mainly because of the rigidity of the pipe, but also the bedding and backfill, which are important. So PCCP is a great product when it's designed and manufactured correctly, but a lot's been learned over time around wire and some of the issues specifically of one manufacturer, mortar, concrete, steel, and the interactions with soil and other corrosion mechanisms. Much of these learnings are being addressed by manufacturers and specs. So if the PCCP is manufactured correctly, what can cause the failure? Next. So as an owner, engineer, and contractor, it's important to understand the installation requirements and all the risks. PCCP is a big, heavy pipe. If bedding or backfill wasn't or isn't being designed and inspected and required on the job site, settlement can occur. That may open up the joint and allow leaks over time that can cause some of these failures. So if gaskets weren't properly placed and tested, if they're pinched or rolled or have corroded, they will leak and it will cause corrosion over time. If these gaskets are placed correctly and the joints weren't welded or grouted correctly, that can also cause failure. Even handling from transport to install, the linings and mortars can be damaged. So it's a very difficult to make a pipe that's contractor proof. Big heavy pipe can be an advantage, but it can also be a challenge. Next. As example of this weight, comparisons for similar sizes as a potential rule of thumb or a quick calculation, PCCP can be about 3 times as heavy as HDPE. So you're handling 1,000 pounds per foot versus 300 pounds per foot in this example, where the concrete, mortar, and joints are all remaining as the manufacturer is critical. So if the contractor's equipment bangs a pipe unloading it or installing against another pipe or the truck or the ground or an excavator or the trench box, and that contractor knocks off some concrete or damages the joints or delaminates the interior exterior coatings, the question is, will they fix it? And that's often where you can have long-term problems, or will the inspector even catch it? So this weight can come into play more long-term as the bedding and backfill isn't compacted correctly. And due to this extreme weight, the settlement can occur and can create some risk of settlement cracks and leaks from this weight. Next. You can go all the way to the next slide, thanks. So besides getting this pipe to the job site and getting it into the trench with proper bedding, there's also a great amount of risk that the welds are done correctly. There's been a lot learned about welding and how to test welding, and then the grouting, which is also extremely important and is usually done by the lowest paid, lowest experienced guy to apply grout. Are you sure they're protecting all the welds? Are the welds actually correct? And then you're correcting all that steel and all the joining mechanisms from corrosion possibilities. And you can see this happens on the interior and exterior of these types of pipe. Next. So that grouting may sound easy and hey, I just got to pack some cement around, some grout around the joints, but it is very complete and challenging and must be done successfully. So even if the labor gets under that pipe and gets that grout where he's supposed to get it and has these 6 inches and 16-inch and 8-inch wide spaces under the joints, they still have to get that grout around in that sleeve. And so what happens a lot of times is these guys just add a whole bunch of water to their mix and that pushes that grout all the way around easily. But now you got a better or a higher water cement ratio, and that's probably going to crack. And then did they really get it down there? Did they really get it compacted? And then on the interior, they got the same issue. Did they really get it up into all the interior space and keep that up there? So joint protection is extremely challenging, but it's also one of the most important aspects of metallic pipelines.
Hey,
so
Mike.
they can also act. Yes, sir.
Oh, sorry, I didn't mean to interrupt you. Hey, one thing I wanted to point out, I know you were going back on the slide with the welding. I wanted to point out a lot of the joints we see that actually leak are done on a Friday, right? Because guys want to get out of there pretty quick. They're in there welding pretty quick and jump out of there. And I think typically those are some of the failures we see are bad welds. And right, if they're not being UT'd or forced to be X-rayed by any chance, who's to know if that's going to leak or not, right?
Right. And I think that's key too, is for the owners, engineers, and even the contractors to understand, what are some options and how can you guarantee that they are installing the pipe to what it's supposed to be done and to protect you on your design life.
Sure. And I also noticed, Mike, you were pointing out on the grouting side, if you look at their instructions on grouting, it's kind of left it to our contractors, right? So, you want sort of a soupy mix, if you will, to go around that diaper, which is an interesting terminology. And then you try to pack it in at the top. Well, if you have, once again, some, the lowest paid there or somebody who's just trying to get this done and not really paying attention, they might not have the consistency correct. So who knows if that grout's really going to hold or be watertight at the end of the day? We're not really sure, right?
Right. Exactly.
If
And
we
so one of the industry solutions to that too, Mark, has been cathodic protection, and we'll talk about some of that as well. Sorry,
If we
Alan.
notice this, that's okay. There's lots of confined space entry requirements as well to get on the inside of this pipe and perform that weld successfully. So, love it. We are having a great conversation about all this stuff. I know we're all excited to be able to get in there and contribute. So you're doing great. Keep going, everybody.
All right. So go on. Oops. Yeah, perfect. So this picture just shows you a really cool product that was created by the industry and certain manufacturers that kind of provide some thrust restraint as part of the pipeline. So it's a great product when it's installed and manufactured correctly and grouted correctly, or has a cathodic protection installed and maintained, where that some of that thrust restraint's in the joint, but that also means that it's got some thrust restraint coming from in the joint. So if you go to the next one. And this kind of shows you a little detail around the grouting challenges and that you need to understand getting that grout into that interior space, making sure that the pipe is lined up, it doesn't move or crack, that this grout doesn't expose the joint or the cylinder to water and wastewater that can be at risk. Even at installation, if this pipe is deflected up or down, left or right, that can crack this protection and enable water penetration into that steel component and makes that design null and void. And does the inspector even understand that? Does he understand the angles of installation or over insertion and then backing it off, and some things that can cause some issues there? Next. So there's been a lot of different joint designs over the years. Some of them are great, and some of them are to accomplish different things on job sites and things of that nature. This is just another type of a joint called the harness joint for restraint. Again, it needs a lot of protection in the correct installation, even things as much as, how much bolt torque is there. And that'll help you with all your thrust and surge events and hammer events, as long as that grout was installed correctly and doesn't crack over time. But if you think about it, that grout is right into a thrust restraint where there is going to be some pressure and some potential movement. So lots to consider when it comes to risks and making sure your pipe is not only manufactured right, but it's installed and operated correctly. Next.
Hey, Mike.
Oh, I'm sorry.
I'm
Yeah.
sorry. I wanted to point one thing out real fast. If you go back to that slide. So if you notice, they're calling out the fillet welds and all that right there on these joints, right? I think one of the biggest things that people tend to forget and or are not really told is that if you start having a weld that's off, let's say you make your joint and you don't shoot it correctly to the next joint, if that weld's off and you don't catch that, other than the leaks that you're going to have, you start having what's called like serpentining, and that whole line starts getting off. So it's extremely important that these welders know what they're doing. And that's why I think you see the two differences, right? You have the welding and then you have the snap ring, because I think they're really trying to figure out which was the best way of getting this straight. Since, to your point, this isn't a very easy pipeline to install and get right just on the first go.
Right. And I do think that as skilled labor becomes more and more challenging, having the right people, the right equipment, the right testing is going to be that much more important and play such a role in the risks and making sure that you get what you paid for. And then we'll have some more discussions about number of people for a crew, skilled crews, data loggers, and testing later. But know your risks and how to estimate the remaining pipeline lifespan can be done. All right, Alan. So this is just showing you a lay schedule. But what can be important for this is from a cost and a timeline standpoint. You know, lay schedule for PCCP can be pretty complicated and time consuming. There's lots of bends and fittings. Because remember, you can't over deflect. You got to hope that that contractor doesn't make it just try to fit, because then he's going to bust up some of those joints in that concrete at the joining. But what always happens in the field is you do encounter some obstacles and some utilities that you weren't aware of. So then you have to go back to the manufacturer and ask them to manufacture this fitting. So that can take some more time and cost and things of that nature as well. So this being said, and to kind of give you an example, if you go on to the next slide, you'll see that this is a typical layout for HDPE, and that it can actually be bent and maneuver around some of those obstacles. So in a rehab situation, it can be in a compression fit or a slip line, and we'll talk about some of those details as well. And when there is a fitting required, there are so many distributors that can manufacture fittings, and that reduces your time and also creates some competitive pricing as well. So for rehab and slip lining or compression fit, not only is the trenchless less social impact, but it also is jointless, and then you don't have the issues of grouting and issues of potential leaks at the joints, but you also have a non-corrosive product. So you can add a new pipeline with pressure and structure capabilities in a failing pipeline. Go ahead, Al. So when might these failing pipelines occur? And what you can find from some studies is that unfortunately the main cause of the accelerated failures of PCCP was an interpace manufacturer called Interpace Pipe that decided to use a class 4 wire that you may have heard about that had hydrogen embrittlement and it was susceptible to that. They were producing this pipe back in the early 70s. As an industry, the manufacturing has been addressed and is no longer used, and other failure learnings have also been added by manufacturers to further reduce risks and failures. But again, contractor and operator proofing can be a key to long-term success. And the key for you is knowing if your pipeline life expectancy is coming due. Next. So knowing when your pipe was manufactured or by who, and understanding the installation conditions and what they were doing or what the testing, understanding your cathotics, if the cathotics have been maintained, understanding if there's been ground shift, leaky joints, hot soils, freeze thaw, climate shifts. I mean, now we're even seeing snow in Florida. So there's a lot of things that are accelerating and that these pipes maybe weren't designed or installed to handle, and they're starting to fail. So one of the benefits of PCCP is that these pre-stressed wires, as they break, they can be an indicator of remaining life. And so there's been this a huge addition called condition assessment, and the owners can now evaluate how many wire breaks or leaks are occurring and when this line may have the catastrophic failure and how to avoid that. And that's the key for this is how to avoid it. So what can condition assessment provide, and why is it such a huge industry? You know, because PCCP is in over 25,000 miles of pipelines. There's dozens of metropolitan areas that have hundreds of miles in their system, and there's others that have 50-mile systems. So as they're approaching this design life or experiencing some premature failures due to some of these things, it's great to know that condition assessment is there and can identify it for you. And then what we're going to talk about is how you could maybe rehab that pressure pipe. I'll let you talk,
Mike.
Al.
Very, very good. Nice synopsis there, Mike and Mark, for your contributions. And yep, we're leading right into some aspects of condition assessment that are tools for you. Here again is all the potential for failure methods and mechanisms, and we'll talk about the tools that could possibly help you try to predict this. One of the things that we're really looking for is to try to achieve the lowest cost option for rehabilitation, and a lot of the data collected during condition assessment is trying to predict exactly when it might fail, which can be a challenge to do. Pete, I think we did pretty good on time there.
Yeah, congrats, guys. Hey, Mike Leathers, I have one question for you. You know, you pulled up that slide on lay schedule, and you know, when you juxtapose polyethylene to concrete, one of the things, Mike Leathers, that I find remarkable is that these guys actually lay down the pipe kind of like they do with ductile iron sequentially down the road in the right of way. Yet with polyethylene, it's totally different.
Right. Agreed. Yeah, you can put it in basically any order you need to, as long as you're, within those, that same DR and the same pressure pipe zones.
Yeah, and these guys, the some of the highest, you talked about lowest paid guys, and some of the highest paid guys are the fusion techs, and they try to keep the fusion machine where it is, and then they do what's called string out the polyethylene along the right of way. So they take the pipe off the flatbeds when it comes from your factory, Mike, and they just stack it there, and then they string out the fusions from that single location. It's really quite remarkable.
Yeah, agreed.
All right, good. So here is kind of what we're looking for that condition assessment. We really want to target those pipelines that could have the highest consequence of failure, and then also the highest likelihood of failure. So those are shown as two different things. The consequences of the failure obviously has social, environmental, and economic costs associated with it. Once you've been through a very large diameter failure, it is very painful, and you do not forget something of that nature. And then that likelihood of failure is spelled out statistically by the Water Research Foundation project that Mike had addressed and talked about. So this can be a desktop data collection or data information analysis for you engineers out there, to be able to look at your pipeline inventory and go from there. They also have Water Research Foundation Manual 4233, which kind of disseminates an entire industry on condition assessment. Things have changed a heck of a lot over the past 25 years as far as the tools that are available to you to do condition assessment. Some that require access and exposure to that pipeline, exactly what that sounds like. You have to access the interior of the pipe safely with confined space entry requirements if you're sending a person down into that pipeline, and excavate down to look at the exterior of the pipeline if we need to get access to that to be able to do any wire continuity tests or even visual inspection of the exterior of the pipe. So sometimes those can lead to costly condition assessments just because we're having to safely access and get down to that pipe to be able to take a look at all those things as well. Infrared thermography essentially looks at some changes in soil temperatures and other things to be able to look to see if there's leaks. That's what we're really checking for. Ground penetrating radar is going to do something similar. That listening and looking now gives us a few more options to take cameras and then also microphones down into the pipe or on the exterior of the pipe to be able to listen for leaks or rather water movement through that pipe. So it is as simple as it sounds, with taking some type of a apparatus, a microphone, and a pair of headphones to the top surface. Now, a leak won't necessarily come up right out of the ground where that leak is. It could run alongside some type of fault within the soil to show itself in another place. So it's not a very precise measuring tool, but you can interpret those results more like an art form sometimes to be able to get you some information in that manner. There's also tools that go inside the pipeline to be able to give us that sound image with a high quality microphone to be able to listen for pockets of entrapped air or leaks through that pipeline as well. So I will caution everybody, if we put a tool into the pipe, we want to be able to get that tool out of the pipe. So that takes just as much planning through that process as trying to pick which tool might be the best for us as well. Then we get down into non-destructive testing methodologies, which will be some of your more expensive ones where we're actually identifying wire main breaks and other things of that nature through this. So this is a good report for you to pull through if you've got that sensitive inventory and you want to look through it. As Mike had said, it's a very large industry itself and very costly. And I will pull this through to show the number of different technologies that have been surveyed through this Water Research Foundation report to try to predict exactly when that failure is. Oftentimes engineers love data. They love to be able to try to predict what that is, when it's going to fail, what condition it's going to be in, and whether or not it could potentially be catastrophic. A lot of the remainder of our presentation here will point out that slip lining of a full section of pipe can be the lowest cost denominator for you. You're going to maximize that productivity because we're taking advantage of all those material properties of HDPE and productivity tools that the industry has pulled together for you. And we are going to put back a good pipe that's going to last just as long, if not longer, than that concrete pipe that we've put into place. We are growing the industry significantly. All those brilliant minds within our resin development side are going to come on and tell you about the improvements to our resin to be able to get to bigger, thicker wall pipes with that high pressure rating that we really need here for you as well. So that bigger and better is our innovation as we're looking to. So we are pushing that boundary fairly significantly. And it's going all throughout the industry itself. The fittings are growing in that size and dimension. The repairs and the ability to fuse that pipeline is also growing in that manner. Each of the machines are designed to take off of the chassis and get down into the excavation to be able to perform that butt fusion in the excavation. So Pete, yes?
Yeah, Alan, this slide, this image that you put up there, so that's that for those regular listeners of the webinar program, that is the Fort Lauderdale project where we did 54-inch DR11. So Alan, that's 200 PSI pressure pipe in Fort Lauderdale, and that's a 5-inch wall thickness. That's an agri pipe made in South Carolina, and we are now making 6-inch wall thickness of significant pressure pipe, Alan. So this is the second project to go in the United States that's a 54-inch DR11.
So those high strengths that concrete pipe is going to give you, we're starting to achieve those very much so in municipal application potable water pipe for us here. So why would we use polyethylene? Tough, that abrasion resistance that we're looking through, the ability for the contractor to work with it in the field. That's that durability that we're talking about. So from that lay schedule, if there happened to be a change within that pipeline, as we see it, sometimes they have to go back to the manufacturing facility to be able to devise a new section of pipe to be able to work around that utility conflict. A lot of times in polyethylene, we just simply cut that pipe, bend it to whatever shape we really want it to go to, refuse it, work around that change. When in doubt, cut it out is what we like to say around here for gouges and other things that might happen during construction, in which case the contractor simply will refuse that pipe and you can refuse it pretty much all the time through that section as well. So here's high density polyethylene used in horizontal directional drill as we see through this. Okay, some of this is making some noise for us. That's that pipe bursting project over there. Trenchless technologies are going to give us that social, environmental, and economic cost savings through this. And these are simply some examples of how we get through that existing concrete pipeline or install via a brand new pipeline as well. So we do have AWWA standards that control working with this, and then also our fabrication facilities can bring just about anything you want to that particular field as well. So there's lots of great benefits that we routinely talk about in a lot of the Alliance for PE Pipes programs. They're simply adherent to that property itself. That leak-free process really gives us that long-term life for that pipe, as well as minimizing the release of any raw sewage if it's conveying sewage, or losing that revenue water or non-revenue water as we're seeing this as well. So Mike, you want to come on and talk to us about the resin?
Yeah, of course. Happy to join. So as it says here, my name is Michael Camara. I am a polyethylene researcher with LyondellBasell, which is a resin producer. So, we work with the likes of Mike Leathers, and he gives us feedback from his customers, and that's how we sort of know where we need to make some advances with our products. You can go into the next slide if you want. So this is sort of a quick intro into chemistry. I'll rush through this pretty quickly, but as I think Peter said in the very beginning, polyethylene is really just made of a bunch of ethylene units. So this ethylene is coming from your natural gas or your lights off your oil feedstocks. From ethane, the ethane's cracked at high temperatures to get this ethylene unit. And then you put those in a reactor with a catalyst and just get a polyethylene from that, but just a bunch of ethylene units over and over and over again. This polyethylene is able to be molten and cooled again over time, which is very useful for fusing. That's one of the biggest features of polyethylene to me, is the fact that you can fuse it. And the way this resin manufacturers tailor this is we change the molecular weight, so the number of units, branches that come off of it. And what we really try to focus on is a balancing of all these different properties to give it good pressure capability, good crack resistance, and good workability, I guess. High density polyethylene is anywhere from like a 940 to a 970 density. Typically, what you're going to see is a 949 to 950. Again, that gives us a good balance of stiffness and crack resistance. You can go ahead.
So Mike, before you go ahead, I just like you to answer one thing. You know,
Yeah, go ahead.
People think they see the pipe showing up on the job site and they, oh, it's polyethylene, it's water pipe. But as you said, you talk to guys like Mike Leathers, and he says, we need better chlorine resistance, or we need better flexibility, or when we went from 38, you know, from the third generation to the fourth generation, we ended up with 25% greater pressure capacity. How do you, as a scientist, I mean, I don't need to know the long answer, but do you really engineer this specifically to be a water and sewer pipe? And if so, could you give us a quick understanding of how that works? Because this is way above my head.
Yeah, so we're, keyed into all the major organizations and standard setting bodies. And like I said, we're working with our customers like Mike, and they're giving us the feedback from their customers on where improvements need to be made. And it's really depending on what the focus is. If the focus is pressure capability, density moves directly with pressure capability. So then we know we need to increase the density of the product, which sort of is nicely laid out here in this graph. If crack resistance is the big component, we know we need to increase some branching, or we know we may need to drop the density while still meeting the 4710 requirements. Lowering the density a little bit gives you better crack resistance. We have not only LyondellBasell, but all the resin manufacturers, we have a good feel of what properties, what things we can change with the resin to give us a given pipe property. So we know how to tweak those in our reactors.
Very, very helpful. Thank you.
So some of this is a little redundant from what Alan just went over, but again, polyethylene pipe resins offer a balance of a lot of different properties. The stiffness flexibility balance, I think, is really key. You want a material that won't give too much under a specific load. So it has to have some stiffness, but you want it, again, to be flexible enough that you can actually work with it in the field. You've seen the images where you can kind of hang it up and bend it around as much as you need. And so I think that's really critical. Obviously, the chemical and corrosion resistance is huge. It's just inherent of polyethylene. It's a relatively inert material that won't really interact with much else there. So in terms of this sort of, I'm kind of leaning into the low sag or low slump a little bit. As these pipe advancements are made, larger pipe diameters are being seen, right? Pete just talked about this 5-inch diameter a minute ago, and as these pipes get bigger, the wall thickness gets bigger, and as the wall thickness gets bigger, the cooling time increases substantially. So one example here, a 36-inch DR9, right? Roughly a 4.3-inch wall thickness. The cooling time for that is potentially 11 hours. That's substantial, right? And so all this time when you have this pipe in this molten state, gravity's pulling on it downwards, right? All this molten material is being pulled downwards. And so then what you get at the bottom, you get excessive material that's pulled there. And then you get this big deviation between your min and max wall thickness, which is an issue. You can be out of the standard. You could be wasting material, which is going to cost you money, right? And that's one of the areas in which we've tried to further engineer these polymers to resist that sagging or slumping to the bottom of the pipe. You can go on to the next slide here. And so again, as I sort of mentioned, that's what we're trying to do, is avoid this sagging or slumping that can take place. These standard 4710 resins that we've used in the past, we see them making up to maybe 2.5 to 3-inch wall thickness resins. 2.5 to 3-inch pipe wall thickness pipes without many issues. For the low sag resins, though, we see them getting up to 6 inches, sometimes greater, without significant sagging or slumping. And they're CC3 rated, so it's fine, meets AWWA requirements for chlorine resistance. It's really impressive, what these resins can do in these types of applications. And I don't know if this is much for me on this one.
No, we're just continuing more, Mike. Thank you so very much for explaining the resin. I know that was quick, but this happens to be a little bit more focused on some of the rehab methods now from then on out. That was great that we're getting good information on growth, continued growth within the industry. So. EPA and the Water Research Foundation has done some reports and information for us about the durability and reliability of HDPE in these larger applications, and this is one that's available for you as well, that you can review and study not just what the PE Alliance has to say about it, but what the Water Research Foundation also has to say. So those low HDPE failure rates are going to help walk us down from that catastrophic failure that we're looking at that really could impact on a larger diameter in that manner. And then we're now starting to grow it even more in that transmission system scenario that we're looking at. That durability and reliability shows us through this 2 million cycle test. So this pipe material, in order to be able to be listed on PPI's technical notes and reports 3 and 4, has to go through a heck of a lot of testing even before it leaves the resin manufacturing facility, and then also even more testing in Mike Leather's performance pipe, or I'm sorry, pipeline plastics facility there itself. Mike, don't hate me. I'm talking a lot at this point in time. So there you have it. So here, this 2 million cycle test really shows us that we're going through quite a bit of testing for that facility itself prior to even arriving on your job site as well. So availability of this pipe material is also increasing significantly as the market is starting to take off, even more so for that municipal application. And all of this innovation continues to happen at manufacturing facilities themselves. We did get a question about surge, so thank you very much for your questions. We have a lot of different questions, and people on the bench are endeavoring to answer those for you. So we're about 30 minutes out now from the end of the presentation. Reminder that the survey at the end is going to be one of the easiest and quickest ways for you to be able to get your CEU or PDH, and then also keep those questions rolling as we're going to go through here. So surge is calculated differently for the 3 main pipe material types at AWWA that we look at and often compete in smaller diameters. That's PVC, HDPE, and ductile iron. High density polyethylene can take a 1.5 times surge for recurring surge, and that happens to be 55 cycles per day, or 2 times that for occasional surge, which is that 6 times a day thereabouts. And the things that happen to create those surge pressures are going to be a valve open, valve close, all valves open, or all valves, some close for firefighting activities is going to give you a large demand for water, where the plants or the tower will respond to be able to deliver all of that water as we're trying to work that firefighting event. Those are the types of events that happen within a distribution system to give us that surge. And that viscoelastic behavior of the high-density polyethylene that gives us the durability, the ruggedness, all of those things to work with it in the field also serve to give us a lower surge pressure due to a higher velocity change corresponding with a surge event. So we do have attenuation capabilities through that because we can produce lower surge pressures in that higher velocity change. Fortunately, the way that these pipe designs are calculated for surge are calculated very differently for the 3 main pipe material pipes that are smaller diameter for PVC and HDPE and ductile iron, as you'll see here through that process. But HDPE continues to push that boundary on that surge, especially for that larger occasional surge, and can handle quite a bit that we have out there. So Evan and Mark, you guys want to come on and start to talk to us a little bit about what options that they could find with your distribution center?
Sure, I'll take this. Name's Mark Christensen. I work with Secor. First of all, I want to thank everybody at the Alliance, Alan, Peter, Mike Leathers, certainly at Pipeline Plastics, and Evan for letting me be here today. We make a lot of our own fittings here, specialized fittings, as well as true flow fittings. So if you need something that needs to match IDs, but yet, the thicknesses kind of vary, certainly we can make that up for you. As you see in this slide right here, certainly there's no limitation in what we can do. Have a lot of machining capabilities to match whatever you may need. A lot of people ask us about matching different pipe materials and things like that, and certainly that's not a hard thing for us to do. Going from HDPE to ductile or PVC, there's fittings out there that we can make or get you in a very quick amount of time. Next slide, please.
Yep. So lots of different options.
Thank you.
Bob and Dan are happy to not have this pipe display anymore, but this is set up to be able to show you that there are anything that you need out there, you certainly have it. You guys also offer fusion certifications, don't you? Training?
Yes, we do. And, a lot of people, I actually come from the RCP world, and, you hear a lot of people say that the fusion certification process is long, which is actually not true. We can certify people pretty quick, about in half a day or so. And one of the most important things about being certified to fuse pipe is not only that you understand the ASTMs and what you're doing, but doing it correctly and making sure that this product lasts for its life cycle, which is expected around 50 years or so. So we want to make sure we have the right people out there. And as a person who's in the field often, I can't tell you the amount of times I run across people in every different pipeline area where they're maybe not certified. So for us in our industry, it certainly helps. Right here's a great example of this electrofusion coupler. As you see, the technician has the cool times written down, the time he started it, the date, the joint that's on there. So certainly if anyone comes across this, they know a lot of information about this joint, and it's not something that's just sitting there. As in different pipelines and materials, you have no idea, right? So on this one, we know what time to wait before we energize this line. Next slide, Ellen. So here's one of the things I like most about I'll let the video play. Go ahead, Ellen.
Yeah. You could talk over it too, if you'd like.
Okay. One of the things I like a lot about this whole process, when you watch this technician put this pipe together and everything, you see it's one person doing all the work. There's not a million pieces of equipment around him. He's there by himself. You could easily do this process and get hundreds of feet done within a day. I think with this size pipe, which looks to be around close to 8-inch, maybe 6, I would think that he could do about 1,100 to 1,200 linear feet a day, just by himself, actually. Maybe some, help at the end of the day with the loader to get things ready for the next day. But generally, that's the best thing about HDPE is being able to cover that amount of linear footage with such a small footprint and a single machine and just one operator.
So with larger pipe, the logistics get bigger, but I'll tell you that the machines and everything that they've designed and pulled together with McElroy to handle large pipes still take in all that consideration and take a lot of the operator portion out of it. And that machine will do quite a bit of that for you. So spend a lot of time the industry has in recognition of productivity tools and making those things happen. Just some more in the field.
Go ahead. Sorry, Alan. I was going to say, and to your point here, you have the poly horse, which realistically your loader could, stack as much pipe as you can on that in the beginning of the day. And that operator can sit there standalone with just that machine and run all that pipe, basically throughput all day long until he's done. And then open cut, your operators are open cut with whatever machine they need. By the end of the day, you could, potentially put in over 1,000 feet of pipe very quickly without having a lot of people in ditch, right, Alan? And then to that other point, if you go back one to that slide, I wanted to show the gentleman in ditch right here as well too. That's one of the things I love most about McElroy equipment is you can go in ditch and do tie-ins extremely easy. The machine stays up there, you bring the machine in, you make your tie-in. In this case, it looks like to be a flange. Do what you need to do and be out of there. Depending on the soil conditions, an operator could dig that in about 20 minutes, get in there, make that tie-in and get back out before it's even lunchtime. So it's a very efficient machine and a very efficient way of getting pipelines put together. Next slide, Alan. Here's probably one of the most important things that I like to see on every job site, which is our data logger. It does a multitude of things. This graph it's showing right now really is pressure over time. And what it does to any, owner operator, inspector, and anybody in between really could get a good idea of the feeling for this weld that's either been done, this first one or even the very last one. Pull up the report and see exactly how everything was done. What it does, it really makes it to where there's no guesswork anymore. You know that the weld's been done correctly. The amount of time that was supposed to be reached, the pressure, it's all right in front of you. You can upload this very easily just by using Wi-Fi or using your cell phone. So that way, at the end of the day, you know, the engineer, project manager, everybody has the correct data. It's very easy to use. And also, it also GPS logs every joint, depending on how you set it up. So, you know, if you need to recall a joint or there's something you don't particularly like, you know exactly where it's at, you know, given a couple feet, and you're not trying to dig up 20 feet of pipe and guess where this issue is, you know, right away where it would be located.
I'm sure that makes all the operators out there very happy and thrilled. It's just once you integrate it into your workflow, it's really easy to specifically get to that. So thank you very much, Mark. I'm going to spend just a couple of minutes that once you decide that you'd like to do slip lining or compressive fit slip lining, how to make sure that your rehabilitation project is successful. And then Mike James will turn around and show us some really good case studies with lots of good live video and other things for us as well. So for slip lining, and compressive fit slip lining in particular, we are looking at making sure that the interior of that existing pipeline is properly prepared for us. So that means anything that may be an obstruction within that pipeline, we want to make sure that that's removed and cleared out. If there's a change in direction as to which we can't pull through that HDPE, we can do an excavation. Any valve, any fitting, anything of that nature is also going to become an excavation through that as we're looking at it. The lengths that we're going to be looking at are going to be, 1,500 feet max type of length when we get into longer pulls. Transmission mains have that kind of distance between valves, oftentimes more so than a distribution system itself, which has more interim block control than a larger diameter pipe. So we're going to properly prepare that internal surface. We can prove it through with what's called a pig, in which case we're pulling through a foam pig in order to be able to prove out that surface to make sure that whatever we're pulling into place there won't get stuck. You can either pull it or push it into place. You'll see the video on the right showing 500 feet being pushed into place in less than 5 minutes once they have adequate access to either side of whatever they're slip lining as well. And you'll see this pull head that's simply fashioned by fusion to that HDPE pipeline on the left for us as well. Now, remember, every fused joint is a fully restrained joint, and the full tensile yield that's provided within the HDPE material then is transmitted directly to that fusion joint. So it is a fully restrained joint, and we're pulling that right along through that process as well. Compressive fit slip lining is extremely unique and only uses high-density polyethylene in the fact that we're taking a larger OD pipe, temporarily reducing the size of that pipe, pulling it into whatever existing pipeline that we're rehabilitating, and then allowing it to relax and regain that shape. That viscoelastic behavior that I talked about before is a change in modulus of elasticity over time, directly related to hoop strength, as we're putting a load on that pipe. And then when we allow that load to relax, the pipe will regain its natural shape and then all of its structural properties that we discussed. So this is circling back to Mike Kamara and talking about the side chains and the density differences and the balance thereof of the resin as it is designed to be able to do this for us. Several different ways to look at it in the field as far as the mechanisms of how to make that pipe smaller through it. It is still a highly specialized field under patent protection, but here's an example of the pig. Here's an example of some heavy-duty scrapers and cast iron pipe, and this is a pipe in the middle that's being forced through that die reducer just to be able to put brute force along that and then pulled into place as well. So here's another example of that on the right coming into this pipeline. So here's exact dimensionalized display of what we're looking at for a pipe being done in compression fit lining. The liquid on the pipe happens to be an oil to grease it right through that way and put it through that forcible die. As you can imagine, there's a lot of force transmitted through the machinery to be able to put this together. And then that die reducer is reinforced at the soil interface to make sure that it does not continue to push through the soil column. Here's just another video of that process itself. We had a quick question about bead removal. Yep, there are plenty of tools available for you for the internal bead removal, as you'll see here, and then also the external bead removal, which has to happen for compression fit slip lining. The friction factors within the pipeline itself are the same with the internal bead. We just see some parts of the country that prefer to have the internal bead removed with very low slope gravity sewers and things like that. So Mike, you want to come on and start to talk to us about your project?
Yeah, sounds good. Thanks, Alan, for having me. And great job, everybody on the call. And Mike Leathers, thanks for joining us. It's nice to have you on. You're one of my favorite vendors, and we appreciate you being on as well. Hey, Alan, some of those pictures you showed before I jump into the slip line a second ago, it's making me think about, and I know we're talking about municipal projects, but HDPE pipe gets used in the most difficult, toughest applications. And what I'm thinking about right now are some of the mining applications that we use it in, where it just really gets beat up and challenged. And they actually compression fit thin wall HDPE into steel pipe to really get the pressure ratings up. And they use it in really difficult applications from 14,000 foot applications all the way down to sea level. They use it for that. You can squeeze it flat, you can squeeze it shut. But I think everybody on this call should know that it's used every single day in the gas distribution network as well. And it's been around forever. So if you're not familiar with it, it's used in the gas pipeline business every single day and well used. So this project that we've got that we're talking about today, we were able to work on a project in Tucson, where I live, in Sahuarita, which is just south of Tucson. We obviously need lots of water in Arizona, and our city was able to take an existing pipeline, PCCP pipeline that had been abandoned. I think it was put in the late 60s and early 70s. It was about 7 miles of pipe that they just abandoned, and they were able to use that pipeline and slip line HDPE pipe inside of it to take it out to some new well fields and go capture some new water that we needed. And it was a great example of using an existing pipeline and actually save some money without having to excavate a whole bunch. So you'll see some pictures here. You see on the right here, we had one of our favorite contractors, B&F, who is well-versed in HDPE pipe. Those guys are experts. They came out, they easily tackled this project, and were able to fuse up all the pipe, test all the fusions, string it. I think Peter talked about stringing it in long lengths. They were actually able to do that, string up a bunch of pipe and then pull it into place. And so you had an aging pipeline that was corroded and leaking, and we rehabbed it and turned it into a brand new pipeline. I think there's a couple of pictures or videos in here that show some of the deflections that we had. There's some examples of the existing pipeline that we pulled out of the ground and the shiny new pipe that went in the ground. We put in, it was a 30 and 36 inch existing pipeline, and we were able to slip line it with 32 inch and 28 inch pipe going in the ground. And you'll see, I think, a couple of videos here. Simple pull head put onto the end of the pipe.
Yeah, so this is, we're proving out the ID, Mike.
Yeah, making sure there's no obstructions on the inside of that PCCP pipe. There you go. Yeah, Peter, you and I were out there that day when they were doing this right over this creek, and they were able to take one of those long strings. I forget, they had like 400-foot strings, I believe, just with a sky lift like you see here, a pull head on one end, and simply pull that right over the creek. We actually used a piece of HDPE pipe on the forks there to help roll the pipe over. But those are all fused joints that are as strong as the pipe itself. And you could get your production up, fuse your joints, pull it over the creek and pull it into your ditch.
Yeah, they're getting pretty creative with that on the excavator and or I'm sorry, the front end loader there to be able to use that. They're also using rollers here to reduce some of the friction across this stone area as well. So
Correct.
pretty cool stuff. Keep going.
Yeah, and I think you're going to see. I mean, there's no specialty equipment here, right? This is all really simple stuff. I mean, excavators and pushing and pulling method both. There's a cable winch down on the one end connected to the pole head, and they're simply using the bucket on the excavator just to get alignment of the pipe as it goes inside of the existing pipeline. And we took the beads off the outside, as you showed earlier, right? Just to eliminate any challenges there. I think most of the beads came off, but you don't always have to do that. You can remove them if you want. It doesn't harm the pipe, but you certainly don't want them hanging up on anything on the inside as well. But this was all done with the normal fusion process, and then you'll see a few spots here where we had to maybe put some flanges or MJ connections on where maybe valves were going to go in place, and so they potholed, and we're able to make those connections there. So you'd fuse one string, pull it through, attach your flange or your MJ adapter, and then do the next string as well. This is pretty common. We're seeing this happening a lot more around North America for aging infrastructure. You know, these pipelines are getting old, kind of like Peter is, and you know, they need to be rehabbed and cleaned up and fixed up and made nice, kind of like Mike Leathers looks in his photo there. Nice and pretty. Here's a good example of the deflection and the advantages. And Peter, you and I were standing above the ditch, you know, wondering how much of a bend we could get. There's a gas line right above it, right? But with our pipe, it actually bends and is flexible enough to get inserted right inside of there. So that was actually done pretty quickly. Again, backhoes and excavators, normal everyday construction equipment.
So we've had some good questions here. The friction factor, the better C factor of HDPE, does that compensate for the reduction in the ID when we're using this? Absolutely. You'd have to really look at your project specific with a hydraulic model or something of that nature to get your actual predicted results that you really want. But in many instances, that internal diameter of a corroded pipe is going to be significantly less allowable flow through that than our HDPE itself. So that's a great question as well. Another question we had was the bucket scratching the pipe? There is a 10% allowable gouge allowance within the pipe itself, and what that actually means is 10% of that wall thickness can be scraped, 10% or less, and give us that 100-year service life of the pipe that we're really seeing itself. So a lot of times the surface scrapes we'd see for dragging the pipe along the surface or something as small as that does not exceed that 10% allowance. Now that's something your construction observer and your contractor would have to really pay attention to as we're going through this. As a construction observer, I walk the pipeline prior to insertion all the time. In pipe bursting projects, what we've seen is after bursting, the fragments of the pipe that remain do not impact that pipe in any way, shape, or form after installation. And once we prove the internal surface of the larger diameter through this process, we're going to know that there's not an obstruction within that pipeline in order to be able to scratch that pipe as well. So great questions. We've got about 6 minutes left, so got a few more slides for Mike to show you just how many great fittings they had available for this project here. And here I'll play the video, but mute it so you could talk over it, Mike.
Yeah, no problem. So these are the MJ adapters that have a stiffener on the inside of the MJ adapter. So when you're connecting your valves to the pipeline, we're using standard valves like you would normally use in your water system and connecting them to these MJ adapters. This project didn't have too many fittings. We did have some MJs on there and maybe a few flanges. Of course, we eliminated a lot of the bends and elbows, which is the other thing too. Mike was talking about the lay schedule that you normally would have for steel pipe or any other rigid pipes like PCCP. With HDPE, you can reduce a lot of your elbows and bends and eliminate a lot of that just because we have that flexibility.
Very durable pipe that's out there in the field, and that also contributes to lowering friction loss across that pipeline itself as we're operating it. Those bends that can be contributed to minor bends or minor friction losses through it sometimes aren't as minor as we think there through that. So that's an important part of it. Now, of course, here our resident engineer Dan Landy and Peter Dyke. I'm assuming that you took this lovely photo, Mike James, and everybody's happy about the success that we had at this project.
Happy. Yes.
Hey, Mike James, a question came up. In these cases, did we grout the annular space at the connections? Like most of this was like 8 miles of polyethylene slip line, but on either end of the 8 miles, did we grout the polyethylene?
No, not in this case. You can do that, and sometimes we do that when we do culvert relining, if we're doing some snap tight underneath, culvert, or in this case, we did not, though. No, this was simply an abandoned pipeline, did not have to grout anything at all. So very simple. And you see in this picture, you see Dan, of course, in there. B&F's an expert at fusion, but this is a T900, McElroy T900 track machine. Those guys are well trained. They had the fusion process down. They had the whole project layout set up really well done well.
Great. Here's another project. This one became 2014 Trenchless Technology Project of the Year. This is one of the earliest, largest compression fit slip lining projects that have been done. And of course, Murphy Pipeline has been pushing the boundaries very much on that particular technology as we come through as well. So if we can have our speakers come back on, we've got a few more minutes here for any last words and advice. This is contact information. I'll definitely take a screenshot of this. Make sure that you complete the survey at the end of it. We had just a rapid amount of questions at the end of this, and love to see everybody involved in that manner. Don't forget that you can talk to us about your project specifics. We love talking about high density polyethylene projects themselves and are here for a resource for you at that time. Mike Leathers, there's a lot of Mikes and Marks. It's been hard for me to keep track of it, guys. Hopefully I didn't get anything wrong there. Go ahead and tell us a few words, and Evan, you'll be next. Mark as well.
Yeah, appreciate the time and just excited. There's a lot of questions about wanting to know more. Feel free to reach out to myself or anybody on this webinar or in the industry. We've got engineers and everybody else would be happy to help you and help you with any of these presentations you're asking about. So thanks.
Yeah. I really appreciate everyone's time today. This is really a great discussion. As I mentioned, we're Secor is not only a large proven source for HDPE pipe and fabricated fittings, but we're also a major McElroy fusion distributor. So we have the ability to support your job wherever it might be. We can help you from a materials perspective, a training perspective, and also an engineering perspective. So reach out to us, any one of us on this panel, and we'd be more than glad and happy to help on anything you guys have.
Certainly, Evan, and follow up with that, I'd like to say, being in the field all the time, if you have run into an issue or you have a question, something just doesn't make sense, please feel free to send me an email or reach out. I'm in the field quite a bit, so there's some things that I see that maybe some other people don't see often, but certainly we're always here to help. Like I said, we do ID matching, things like that. Generally at Secor, we can turn fittings really fast for people. So if you run into a situation where you need something now, give me an email. Well, we can help you out. So we're always here for you. Thank you.
Okay. We had a lot of other questions as well related to other trenchless technology methods. We do 17 webinars, as Pete mentioned. So we definitely will do a webinar on what you've asked. This one happened to be larger diameter and then also presenting additional information to the best of our ability on how to construct or construction methods for pre-stressed concrete cylinder pipe and how you might be able to operate, own, and maintain those as well. So we try as hard as we can to be a good resource with lots of different information. We know you got limited ability to attend these, and we truly appreciate your time today with the Alliance, and we hope we provided some high-quality educational content as well as good information on how to get your next HDPE project going and out the door. Any other comments or concerns? Okay. Thank you so very much. Don't forget to fill out the webinar survey at the end of this, and then keep us in tune. And if you're in our local area, come on and join us for a roadshow. We'd love to talk about it.